Hi everyone. In this video, we're going to look at just a different way of finding the definition of the derivative or representing the derivative, which remember is slope of the tangent line, as the limit of the slopes of the secant line. Okay, so we're going to still use the difference quotient, which is slope of the secant line, but we're just going to kind of represent this scenario a little bit differently. Okay, the overall concept is the same. The question is, how do we find slope at a point? And so if I were trying to find, let's say, the derivative at point P or at x equals a, then I would be trying to find the slope of this tangent line. And, so the question is still, how do we find slope at a single point when we need 2 points to find slope? The answer to that is still that we find slope of the secant line, and then we move point Q closer to point P, okay? But instead of letting x approach A as point Q gets closer to point P, we're going to represent the distance between the 2 points as h, okay? So the distance between x and a is going to be h. And so that means, if this is a, then we can also call this point a plus h. Okay, because, if we're at a and then we add h units, we're now at a plus h. Okay, so that just means that our y values are now f of a and f of a plus h. Okay, the only thing really changing is this value. Previously we called that f of x, and now we're just calling it f of a plus h. And we're just letting the distance between a and x equal h. Okay, so this is what we then end up with. We have this scenario. So the slope of the secant line would be f of a plus h minus f of a. That would be the rise. Over h, which is our run. Now, initially, you could think of that as a plus h minus a plus h minus a. But your a's are going to cancel, and so that always just ends up being h. So it's just a different way to represent that difference quotient, but the overall concept is still the same. This is a way to find slope of the secant line, and then to find slope of the tangent line, we're going to move point Q closer to point P. So as Q approaches P, that means that H is now approaching 0. Okay, as Q gets closer to P, this distance that we're calling H is now getting smaller and smaller. And so we can say that this is the limit now as H approaches 0. And this would equal the derivative at x equals a. Okay, so this is just a little bit different way to represent that same definition. Sometimes, so really there are two definitions of the derivative. Some people call one of them the alternate. I guess we could call this one the alternate, but I see them done interchangeably. So anyway, just know that there are two different ways to write the definition of the derivative. What we learned in our first lesson, and then this definition. But both definitions are where you are finding the limit of the slopes of the secant lines. Okay, so the overlying or underlying concept is still the same. All right, but let's look at an example. This is actually the same example that we did in our using that first definition of the derivative. So I just kind of wanted to show you, using the second definition of the derivative, how we would get the same answer. Okay, so this time we are going to use our second definition of the derivative to find f prime of -1. So this time we're just going to use our new definition, which is the limit as h approaches 0 of f of a plus h minus f of a all over h. All right, just like we did before, we're going to replace a with -1. So this will be the limit as h approaches 0 of f of -1 plus h minus f of -1 all over h. And then we're going to do some substituting. Okay, so we have got to find these two values. We've got to find f of -1 plus h, and we have to find f of -1. Okay, so let's do that. Now to find f of -1 plus h, remember that means that we're going to plug in -1 plus h into f of x. Okay, so this would become, this is like a composition of functions. We're going to replace x with -1 plus h. Okay, so that would be 3 times -1 plus h squared plus 2 times -1 plus h. Okay, now to simplify this, we will FOIL here. Okay, because remember, -1 plus h squared means -1 plus h times itself. Okay, so we'll end up with 3 times, and then I'm going to FOIL. So I'll get -1 times -1 is 1. -1 times h is -h. H times -1 is -h. H times h is h squared. Okay, then we'll just distribute. We can distribute 3. We can distribute a 2. So that'll end up being -2 plus 2h. And then let's combine like terms. So it looks like we can add the 3 and the -2. So that'll equal 1. Okay, we can add the -3h and the -3h, that's -6h, but then plus 2h will be -4h, and then plus 3h squared. Okay, now I'm going to find also f of -1. So that's a little bit easier. We're just plugging -1 in for x. Okay, so we'll end up getting 3 minus 2, which will equal 1. Okay, now we can substitute these values in our definition of derivative. Okay, so this is coming down here now. So f prime of -1 is going to equal the limit as h approaches 0 of f of -1 plus h. Okay, remember that ended up equaling 1 minus 4h plus 3h squared. Okay, minus f of -1. That ended up equaling 1, so we'll have -1. Okay, all over h. And then with a little bit of simplifying, we'll be able to evaluate this limit. Your 1s are going to cancel. Okay, and we can factor an h out of the numerator. So by factoring h out, that'll leave me with -4 plus 3h all over h. The h's will simplify, and then I can just plug in zeros to evaluate my limit, and it ends up equaling -4. So the derivative at x equals -1 for this function is -4. Okay, so again, you guys, just a little bit different way to find the derivative using a second form of the definition of the derivative. Okay. One other thing that I wanted to show you in this video is, in addition to finding slope of the tangent line, we can also write the equation of the tangent line. So to do that, we use point slope form, which you usually learn back in Algebra 1, which is y minus y sub 1 equals m times x minus x sub 1. Okay, this is how you learn point slope form in Algebra 1, or maybe Algebra 2. Now, we could rewrite point slope form using function notation, okay, and then also the notation of the derivative. So instead of y, we will use f of a, and instead of m for slope, we'll use our notation for the derivative, which is f prime of a. Okay, and then instead of x sub 1, we'll just use a. So for instance, we could rewrite this equation as y minus f of a equals f prime of a, which is the derivative, which is slope, okay, times x minus a. And then sometimes you'll see it written where we solve this equation for y, and so we might add the f of a over. And so you could also write it as f of a plus f prime of a times x minus a. And that's just solving for y and adding the f of a over to the other side. Okay, so this is our equation of the tangent line in point slope form. All right, so let's look at an example. We want to find not only the slope of the tangent line, but also the equation of the tangent line. Okay, so again, if you just remember the equation of the tangent line, and honestly, it's fine if you remember it. You could just remember it as point slope form, but I'm going to go ahead and use our, because we're doing calculus, so we want to use our calculus notation. Okay, so you guys, first of all, we already know a equals 3, okay? So we already know this will become x minus 3, just replacing a with 3. Now, the easier thing to find is f of a. So that just means we're finding f of 3, which means we're just going to plug 3 in for x into our function. Okay, so that'll end up being 3 squared is 9, times 2 is 18, plus 30. Okay, that'll equal 48. Okay, now what's going to take a little bit more work is finding f prime of a. To find f prime of a, we're going to use our definition, and we'll use our new definition. So the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, and then the first thing we'll do is replace a with 3. Okay, and then we're going to have to find f of 3 plus h. I'm going to mark that in a different color. All right, so f of 3 plus h means that we're going to plug in 3 plus h in place of x. So this will become 2 times 3 plus h squared plus 10 times 3 plus h. Okay, we're just going to simplify this. So I'm going to start by FOILing the 3 plus h. So I'm just going to go ahead and work that out in my head if that's okay. We'll end up getting 9 plus 6h plus h squared. Okay, so then we'll distribute the 2 and the 10, and so we'll get 18 plus 12h plus 2h squared plus 30 plus 10h. Okay, and then we'll just combine like terms. So 18 plus 30 is 48. 12h plus 10h will give me 22h, okay, plus 2h squared. All right, we got to find f of 3. So all I'm going to do is plug, oh, and you know what? We already found f of 3, sorry. We already found f of 3 right here, which is 48, so I don't have to find that again. All right, so I'm ready to go back now to my limit. Bring this down here. So f prime of 3 is going to equal the limit as h approaches 0 of 48 plus 22h plus 2h squared. Okay, minus 48, and that's from our f of 3. Okay, all over h. Now, you guys, with this form of the definition of the derivative, usually what's going to happen, because to evaluate this limit right now, if we're plugging in 0 for h, we're going to end up with 0 over 0. So we really honestly have to get rid of the h in the denominator to be able to evaluate this limit. So normally what happens is that your constants are going to cancel out. So if you have done your calculations and you don't see those constants cancel out, you've probably done something wrong in your calculations. Because usually from here, it follows the same order. Your constants cancel, which then allows you to factor out an h from the numerator, which that h is going to cancel with the h in the denominator, which then allows us to use direct substitution and plug in 0. And so we end up getting 22. Now, this is f prime of 3. So I'm going to go back to my equation because that's ultimately what we were trying to do. And f prime of 3 equals 22. So this is the equation of the tangent line. That's our final answer that we were trying to find. And the equation is in point slope form, which is fine because the directions didn't specify what form to write the equation in, but sometimes you might be asked to write the equation in slope intercept form, and that's okay. In that case, you would just convert point slope form to slope intercept form, meaning you would just solve it for y, okay, and you'd have the equation of the tangent line. All right, you guys, so we'll definitely practice this some more in class tomorrow. As always, thank you for watching and have a good night.